All right, guys, we are starting our last unit, Unit 5, and this unit is about geometry. So we're finding area and perimeter of figures, two-dimensional figures tonight, and on Monday we're finding volume of three-dimensional figures. So anyway, let's get started. I've enjoyed teaching you guys this summer. So anyway, I just wanted to throw that out there. All right, so the first thing we're going to talk about is perimeter. It says perimeter is a one-dimensional measurement that is taken around the outside of a closed geometric shape. Let's start our discussion of the concept of perimeter with an example. Joseph does not own a car, so must ride the bus or walk everywhere he goes. On Mondays, he must get to school, to work, and back home again. His route is pictured right there. Starts out at home, has to walk to the school, walk to work, and then back home again. So basically, his route, if we add up how far he walks, we're basically finding the perimeter of this triangle. So the obvious question to ask in this situation is how many miles does Joseph travel on Mondays? So to compute, we add, it should say we add each distance, 3 plus 6 plus 6. So he travels 15 miles on Mondays. So basically that's what we've done. We've figured out what is the perimeter of this triangle. So notes on perimeter. Perimeter is a one-dimensional measurement that represents the distance around a closed geometric figure or shape. So for example, if you have a picture that looks like this, and it's asking you to find the perimeter, well, you can't find the perimeter of this figure because this is not a closed figure. So in order to find the perimeter, you have to have a closed figure like that. All right, to find perimeter, add the lengths of each side of the shape. If there are units, include units in your final result. Units will always be of single dimensions. For example, feet, inches, yards, centimeters, etc. So it doesn't really matter what the shape of the figure is. So here we have a square, and letter B we have a rectangle. Our last example was a triangle. It doesn't matter if it's a trapezoid, an octagon, whatever you have. In order to find the perimeter of geometric shapes, all you do is add each side. So our square has 4 sides that are each 3 units long. So the perimeter of this square is 12 units, whatever your units are. All right, sometimes you have to make assumptions if lengths are not labeled. So for example, our rectangle, even though we only see 2 numbers, of course our rectangle has 4 sides. So if this side over here is 12 feet, we're going to assume that this side is 12 feet, 8 feet here, 8 feet here. So 8 plus 12 is 20. 20 doubled is, the perimeter is 40 feet. All right. All right, so example 2, how do we find the perimeter of this more complicated shape? You just keep adding up those sides. So letter A, I don't even know what this shape is, but to find the perimeter of it, we're going to add each side. So we're going to add 7 plus 4 plus 4 plus 5 plus 6 plus 2 plus 6. And we get what? 7, 8, 9, 10, 11, 15, 20, 26, 28, 34 units. 34 units. And letter B, this is a trapezoid. So trapezoids have exactly 1 pair of parallel sides. So the top and bottom are parallel to each other. So we're going to add up the 4 sides. So we have 8 plus 6 plus 5 plus 6. So we have 14, 19, 25 inches. And when you're given the units, always include those units. All right, so why don't you guys try, are there more than 1 page to side? No, everybody just pause the video and try those 2 problems, please, letter A and B. All right. So hopefully you guys answered all these questions, or both of the questions, I should say. All right, so letter A, find the perimeter of a rectangle with height 6 inches and length 12 inches. So hopefully you remembered, even though you see two numbers there, rectangles have 4 sides. So basically we have 18 and 18. So this is going to be 36 inches. Letter B, find the perimeter of each of the following. So if we have a square with one side that's 2 feet, since it's a square, basically that means all the sides are 2 feet. 2, 4, 6, 8. So the square has a perimeter of 8 feet. A square with side 4 feet, so we have 4 sides that are 4 feet, so that's going to be 12 feet. No, it's not. It's going to be 16 feet. Not 12, silly. 16. And then it says a square with sides that are 16 feet. So there's 16 feet on each side. There's 4 sides. So our answer is 64 feet. All right, I think we did all those. Okay, if you look closely at the shapes in the previous examples, you might notice some ways to write each perimeter as a more explicit formula. See if the results from what we have done so far matches the formulas below. So when we have a triangle, that means obviously we have 3 side lengths. So the perimeter equals the sum of the 3 side lengths. If we have a square, that means basically all 4 sides are the same. So we could either add the same digit 4 times, or in other words, we're going to multiply the side length times 4. That makes sense. And then a rectangle, we're going to have 2 sides that would be A, and then 2 sides that are B. So basically you could double B, you could double A, and you can add those 2 side lengths together. You double both sides, add them together, and you get the perimeter. So you can think of it that way, or you can just think I add up all the side lengths to find the perimeter. All right, so now circles, if you find the distance around a circle, I guess technically it's the perimeter, but because it's a circle, it's not called perimeter, it's always called circumference. So circumference is literally the distance around a circle. It says, you may realize that we have not yet discussed the distance around a very important geometric shape, a circle. The distance around a circle has a special name called the circumference. To find the circumference of a circle, we use the formula below. C is equal to 2 times pi times the radius. And in this formula, this geometric symbol, or it's a Greek letter, is pronounced pi, and is defined as the circumference of a circle divided by its diameter. So that's where the number pi comes from. If you take any circle in the world, no matter how small or big, and you find the circumference of it, and you divide the circumference of any circle by its diameter, by the distance across the circle, you will always get 3.14, etc. Pi. That's what that symbol symbolizes. It's any circle's circumference divided by its diameter, and you're going to get that magic number 3.14, which is what we approximate it to be. But pi is a non-terminating, non-repeating decimal. It goes on and on and on forever. It never repeats and never terminates. But when we're asked to give an approximate answer, we usually, almost always, round pi to 3.14. Okay, so like I said, in this formula, the letter R represents the radius. So the radius is the length halfway across the circle. If you're given the length across the whole circle, the length across the whole circle is the diameter. Okay, so you can think of this formula in 2 ways. The circumference is equal to twice pi times R, because that's the radius, or if you have the diameter, you can say the same thing would be pi times the diameter. The 2 goes away because twice the radius is the diameter. So these two formulas are exactly the same thing, okay? So just keep that in mind. All right, note, remember that in a formula we're computing the circumference C equals 2 pi r. We multiply as follows, usually substituting 3.14 in place of pi. You always have to read your directions. Often the use of parentheses will help you make the different parts of the formula easier to see. So those decimals and those multiplication symbols with dots look a little confusing. So instead, if you kind of put everything in parentheses to show multiplication, that sometimes looks a little cleaner. That's all they're saying right there. All right, so find the circumference for each of the following circles. Leave your answer in exact form first, and then in rounded form to the hundredths place. Note that when a radius is given, its value is centered above a radius segment. When the diameter is given, its value is centered above a diameter segment. So that just means since this line is solid, 12.44 is the diameter. Since this is half a line, or the line goes halfway across the circle, obviously this is the radius, okay? Now, it's telling us to give two answers. The first one in exact form, the second answer in rounded form. So leaving it in exact form means that we don't convert pi to a number, to 3.14. So in this situation, the only things that we're going to do is we're going to multiply 2 times the radius and leave it in pi form. So 2 times 4 is 8. So the exact answer of this circumference is 8 pi inches. 8 pi inches, okay? Now the second answer, they want us to give a rounded answer, which simply means we are going to turn pi into 3.14. So we're going to multiply 8 times 3.14. And in our calculator, we get 8 times 3.14, and my answer is about 25.12 inches, okay? Now, as you get higher in math, you know, it will make a big difference in whether you have an exact answer or if you have an estimated answer. Now, my calculator, I have a scientific calculator, and I actually have a pi button on my calculator. And so if I multiplied 8 times pi, I'm going to get an answer close to 25.12, but it's not exactly. If you'll see, the top number 25.12 is when I estimated pi, and the bottom number, you see that it's quite a bit, you know, a little different. I mean, that's still about $25.13, right? But anyway, the pi symbol on a calculator, if you have one, it will give you a different answer if you use the pi button, but probably your calculators are just the standard calculator. So that's why we're going to use 3.14, so we all have consistent answers. All right, and then letter B, this time we don't have to double the radius because we are already given the diameter. So on letter B, our exact answer would simply be 12.44 pi. That's the exact answer, meters. And then our estimated answer, we're going to multiply 12.44 times 3.14, and that would be 39. It says we're rounding to the nearest hundredth, so it's 39.06 meters. So that's our estimated answer. So really, we would have squiggly. That means about, since we're estimating. The first one's exact, the second one is an approximation. Alrighty. So the takeaway is always read the directions carefully when using pi as to whether you need to round pi or give an exact answer. All right, number 5, find the circumference or perimeter given in each described situation below. Okay, so this is a you try section. So you're going to answer A, B, C, D, E, and on the next slide, C, D, E. So you guys try all those problems on your own, pause the video, and then come back and check your answer, please. All right, so letter A says find the perimeter of a square. So squares all have the same sides, the same length sides. So basically we're gonna multiply 2.17 times 4. So 7 times 4 is 28. 4 plus 2 is 6. 8, and then I have 2 numbers behind the decimal. And so the answer is 8.68 feet. Find the perimeter of a rectangle with sides 2.4 and 3.8. So I'm going to double 2.4, and I'm going to double 3.8, and then I'm going to add them together. So this will be 8.4, this will be 7.6, and when I add those together, I get 16 units. 16 units. All right. Letter C, find the perimeter of a triangle, which is 2, 5, and 7. 2, 5, and 7. So that would be 14 units. All right, letter D, find the circumference of a circle with a radius of 6 inches. Present answer in exact form and also compute using 3.14 for pi. All right, so the circumference, so this is the radius. So we're going to use 2 pi r. So 2 times 6 is 12. So my first answer is going to be 12 pi inches. And then my second answer is going to be 12 times 3.14. So 12 times 3.14, whoops, is going to be about, I should put about 37.68 inches. Okay, so this is our exact answer, and this is our estimated answer. All right, let me clear my screen here. And then letter E says, find the circumference of a circle with a diameter of 14.8, present answer in exact form and also using 3.14. So letter E, the first exact answer would be 14.8 pi inches. That's the exact form. And then the second form, or the second answer, is 14.8 times 3.14. And I got about 46.472, or it says to the 10th place. So really it would be 46.5 inches. That's the approximate answer. All right, moving on our next page, find the circumference of a circle with a radius of 3 meters. So we're going to say it's going to be 6 pi meters, or an approximate answer would be about 18.84 meters. Letter D, find the circumference of if the circumference of a circle is 324 centimeters, what is the radius? Oh, that's a good question. All right, so basically it's telling us that they're going to give us the circumference. So let's start with our formula. Now this time they're giving us the circumference. This time they're telling us that the circumference is 324. We want to know what is the radius, right? Well, I want to solve for r, so I need to get rid of times 2 pi. I need to get rid of times 2 pi. Well, I'm going to assume that we're going to use 3.14 for pi. So 2 times 3.14 is 6.28. All right, so now the only thing that's being done to R is being multiplied by 6.28. Well, the only way to get rid of multiplication by 6.28 is to divide both sides by 6.28. So I'm going to bring up here what we just wrote down there. So to get rid of multiply by 6.28, we're going to divide both sides by 6.28. So the radius is 324 divided by 6.28, and it gives me about 51.59. I don't know what to round to. The hundredths would be 51.59 centimeters. That's the radius. All right, did you guys see how I did that? You have to plug into the formula what you're given. Well, you were given the circumference. That's why I put 324 on the left side of the equal sign. On the right side, I could multiply 2 times 3.14, 2 pi. And then to get rid of being multiplied by 6.28, the only way to get rid of that is to divide by 6.28. All right, letter E, find the perimeter of a triangle whose sides are, goodness, that's, I don't even know how to draw that. 5, 6, and 40. That can't be right because 6 is way too long. But anyway, so if we added up 40 plus 6 plus, oh, because it's 40 inches, you guys, I was not paying attention. So that makes a big difference, doesn't it? So we have a choice. We either have to convert all three numbers to feet, or we have to convert our inches into feet. Or did I just say that? We either have to turn all of our numbers into inches, or we turn our inches into feet. Well, I'm gonna, since that's just one number, I'm going to turn my 40 inches into feet. Let me get rid of all this stuff. All right, so 40 inches. So how many inches are in a foot? Well, it's 12. So we're gonna divide 40 by 12. So 12 will go into 40 3 times. 3 times 12 is 36. So there would be 4 inches left over, or in other words, 3 1/3. Okay? So 40 inches is 3 1/3 feet. All right, now that makes more sense as a triangle. All right, so the shortest side is 3 1/3 feet. We have 5 feet and we have 6 feet. So we're gonna add 3 1/3 plus 5 plus 6. Now this is getting tricky because in order to add these, we have to have common denominators. Well, we can leave this as a mixed number, but we have to turn these into, well, we won't. We'll go ahead and turn it into a mixed number. So this will be 3 times 3 is 9 plus 1. So this is 10/3. If we turn 5 into a fraction, it's 5/1 plus 6/1. Now, if this is a 3, we have to make these common denominators, so we have to change the denominators to 3. So we're going to multiply the bottom times 3 and the numerator times 3. All right, so we have 10/3 plus 15/3 plus 18/3. So now we can add our numerators. We have 10 plus 15 plus 18, and we get 43. Well, 43 divided by 3 would be 14. I could just write it as, I could write it with a decimal, 14.3. We can leave it as 14.3, or we can leave it as 14 1/3 feet. 14.3 repeating, or 14 1/3 feet. So that one was tricky. So hopefully you didn't add 40 plus 5 plus 6 because it wasn't 40 feet. It was 40 inches. So I don't know if I tricked you guys. I almost tricked myself. All right. Well, let's see. Uh-oh. All right, so this is finding the perimeter around non-standard shapes. So this is like an ice cream cone, which I love ice cream cones. So now I'm mad because I don't have one. But anyway, it says find the distance around the following shape, round your final answer to tenths as use, I think it should say, and use 3.14 for pi. All right, excuse me. Now the reason it's telling us about pi is because this top of our ice cream cone is half a circle, right? Half a circle. So the distance around a circle, of course, is found by finding the circumference. So circumference, I think I turned my pen off. So circumference is found, what is going on? Circumference, remember, is pi times diameter, or 2 pi r, right? But 3 is going to be the diameter of a whole circle. So if my circle continued, 3 is the diameter, right? I understand we only have half a circle. We'll deal with that in a few minutes. All right, so basically we want to know if this side is 15 inches, I betcha we're going to assume this side is 15 inches. So for the perimeter of the cone, we already have 30 inches, right? Well, this part right here is not on the outside, so that doesn't count for perimeter. But the reason we have to know this length right here is, it is because it is the diameter of our circle, or our half circle. All right, so it tells us to use 3.14 for pi. So we're going to multiply circumference times 3.14. Circumference equals 3.14 times the diameter. But since this is half a circle, I'm going to divide our answer by 2. Okay? So I'm going to multiply 3.14 times 3, which is 9.42 for a whole circle, and then we're going to half it. So 9.42 divided by 2 is 4.71. So finally, the perimeter of our half circle is 4.71. We're going to add that to 30 for the bottom of our ice cream cone, and our total perimeter is 34.71 inches. That's the perimeter of our whole ice cream. All righty. So even though we didn't add 3 for part of our perimeter, we had to use 3 to find the circumference of the top of our ice cream cone. All right, Wally wants to add a fence to the back of his house to make some room for his children to play safely. He began measuring his yard, but got distracted and forgot to finish measuring before he went to the store. If he remembers that the back wall of his house is 15 yards long, so the back half of his wall is 15 yards long, does he have enough information to buy the fencing he needs? Well, yeah, he does, because this back section of the fence equals the length of his house plus 3 feet plus 5 feet. So then we would know how much fencing he needs to buy. So the first thing I notice is that we have 2 different units of measurement. So we can't use feet and yards. So probably the easiest thing to do is to turn our 15 yards into feet. So how many feet are in 1 yard? Well, the answer is 3. So if this is 15 yards, well, 15 times 3 is equal to 45. So this, no. What? What did I just do? I don't know what I did. Anyway, what did I say? 45 feet? Yeah, 45 feet. So now we know, so we don't need fence right here. Back of Wally's house, we're not going to put a fence right outside his back door because then he couldn't get into his backyard, right? So, but the reason we need to know that this is 45 is because this fence is going to be 5 plus 45 plus 3. So 53. So he needs 53 feet of fence here, right? 53 feet. We need 10 feet here. We need 10 feet here. We need 3 feet and 5 feet. So we need 53 plus 10 plus 10 is 20. That's 73. And then we're going to add 5 plus 3, which is 8, which tells us that he needs 81 feet worth of fence. Okay? 81 feet worth of fence. All right, so let's look at the next question. It says, Wally successfully fenced his yard, but now he wants to add some landscaping to create a grassy area as shown below. So he wants this grassy area right in the middle of his backyard. It says, Wally needs to get sod that is sold in 1 foot by 1 foot square. So 1 by 1. How many squares should Wally buy? So if this is 6 feet long and 5 feet wide, we want to know how many different 1 foot sections of sod we could put in there. So basically what we need to know is what is the square footage. So to find the square footage, that's the area, right? So the area is going to be equal to the length times the width, or some people say base times height, whichever one. So basically if we multiply 6 feet by 5 feet, we get 30 feet squared, right? 5 times 6 is 30, and feet times feet is feet squared. So the area of this backyard grassy area is 30 feet squared, so he would have to buy 30 of these little squares of sod, which is what this tells us right here. So area is just base times height or length times width. All right, notes on area. Area is a two-dimensional measurement that represents the amount of space inside a two-dimensional shape. To find the area, count the number of unit squares inside the shape. If there are units, include units in your final result. Units will always be two-dimensional. So for example, feet squared, squared yards, squared miles, so on and so forth. To find the area for each of the shapes below, remember to count the unit squares inside the shape. So basically they want us to kind of visualize that this is a 3 by 3, right? So if we count these 1, 2, 3, 4, 5, 6, 7, 8, 9, which is what we would get if we multiplied base times height. 3 units by 3 units is 9 units squared. All right, 6 units by 3 units, we're going to multiply 6 times 3, 6 meters times 3 meters, and we get 18 meters squared. Is there a pattern that would make our work easier? Yes, instead of drawing these little squares, we're just simply going to multiply the two-dimensional, the side lengths. All right, so now we have to find the area of a triangle. So when you have a triangle, sometimes you have a right triangle. So a right triangle has one right angle, right? So when you're finding the base and the height of triangles, you have to have that 90-degree angle. So if you look at letter B, this is not a right triangle. However, they gave us the height because they gave us a straight line that creates a 90-degree angle with the base. So you have to have those two perpendicular lines. Perpendicular come together and make 90-degree angles. So do you notice that this diagonal line is longer than the height? And that's always true. A diagonal is always going to be longer than a perpendicular, two perpendicular lines, right? It just is. So when you have triangles, you have to look for that 90-degree angle, and where those two meet, where that 90-degree angle is, those two lines, the lengths of those two lines are your base and your height. So 5 is the length of this line, but it's neither the base nor the height, because the 5 doesn't create a 90-degree angle with any other side. Even if you have a crazy looking triangle like this, Arr. If you have a crazy looking triangle like this, there's no 9-degree angles. They would have to give you like imaginary lines to tell you what the base and height is, okay? But when I looked at your homework and your quizzes, I didn't notice any of them like that. But anyway, anytime you find the area of a triangle, you have to have a 90-degree angle. All right, so anyway, so basically these say the same thing, they just look a little different. So the area of a triangle is found by finding half, 1/2 times the base times the height. Or another way of saying that is you multiply your base and height together and then you half it, you divide it by 2. So 4 times 3 is 12. So half of 12 is 6 units squared. All right, here on letter B, our base and our height is 12 and 9. So 12 times 9 is 108. And we're going to half 108 and we get 54 units squared. That's how you find the area of any triangle. All right, now finding the area of a circle. So when you find the area of any circle, this is always your formula. Area equals the pi times radius squared, pi r squared. So either you're going to be given the radius, like in this one, or the diameter. So if you're given the diameter, you have to get back to the radius by halving the diameter. So if the diameter on letter B is 16, that means the radius is 8. And that's very important because when you square a number, that's not like doubling it or halving it, right? You're multiplying a number by itself. So you're going to square 5. 5 squared is 25. So if you have an exact answer, the area is 25 pi units squared. Or we're going to multiply 25 times 3.14. So 25 times 3.14 is 78.5. And that's an estimated answer. Okay? So for letter B, since our radius is 8, we're going to square 8 and we get 64. So our exact answer is 64 pi. Or our estimated answer is 64 times 3.14. 3.14. And our estimated answer is about 200.96 units squared. So that's always the formula for area of a circle, pi r squared. All right, let me see where we are right now. All right, I think I'm gonna stop right here for a few minutes. I'm gonna take a little break, take my little dog for a walk, and then we will jump back here with example 9 when I get back. All righty, see you in a few minutes.